My name is Jesslyn Dace. I am a master's student in the Department of Mathematics and Statistics, and I worked with Dr. Shapla on this statistical analysis. We studied the multivariate analysis of body fat percentage in adult males. The data that we had to work with came from Dr. Fisher, who is a professor at Brigham Young University, and the data set contained records for 252 adult males. And for this study, we considered 15 of the variables. For our response variables, we used two different ways of calculating body fat percentage, one using Rose-X equation and the other using series equation. Both of those equations use density, and so it requires the subject to be placed underwater and calculations are weighed that way. This is a very costly procedure to implement. And then using our predictor variables, we have age, which is in years, weight, which is in pounds, height, and then we have 10 body circumference measurements for various parts of the body. And we would like to see if we can use those predictor variables to predict the body fat percentage in a less costly way than full body submersion. Our analysis includes multivariate regression, factor analysis, and principal component analysis to accomplish the objectives of this study to see if we can find a less costly method of estimating body fat percentage in adult males. Since the Wilks lambda value is less than the critical value, then we can say that there is a relationship between those response variables and the predictor variables. So there is a relationship between age, weight, height, and the body's circumference measurements and those body fat percentages calculated through density. So we can use the other methods of measurements to predict what the body fat percentage will be. Since we did find that there was a correlation between the measurements and the body fat percentage, we wanted to see if we could narrow down the variables that we needed. So we did a factor analysis and looked at the correlations between the different measurements. And the correlation matrix showed that weight and then the 10 body circumference measurements, they're highly correlated among themselves. So the body circumference measurements and weight gave similar information to our analysis. And then age and height had weak correlations with all the other ones, so they were very different from the weight in the body circumference measurements, and they were also very different from each other.